Hi, my name's Glenn Conlon of Canon Technologies, and I'd just like to cover some outdoor cabinet product and examples and some of the measurements we take to calculate the thermal climate requirements for your cabinet needs. Obviously, we have several markets that we actually focus on, and one of the things we do during looking at this actual markets is we look at the technical requirements, and some of those technical requirements can include obviously EMC, thermal management, environmental, EMC, anti-vibration, seismic requirements, etc. What I'll do in this presentation is look at some of the base designs we work off, an optional Canon Guard system, which is a remote monitoring system, and then example of some of the certifications and approvals we have for our standard product range, and give you a few project examples. So specific market focused, which Canon have been heavily involved with for 40 years now, is within the transportation sector. Those include road, air and rail. Rail is a primary focus with all the developments taking place within the network rail infrastructure, and include things like CIS, CIS, signalling, some of the monitoring systems, etc. Another area is in development of communications, the Internet of Things, autonomous vehicle communications, also things like broadcast communications and rural broadband development. On the security and surveillance, we do a lot of work with the military, defence and civil applications to provide obviously the necessary housing to house sensitive active electronic equipment which is used within the security and surveillance market. So what do we look at when we're looking at putting together a proposal for an outdoor cabinet? Well, one of the things we need to understand is the size of cabinet that's going to be required, and that's obviously calculated understanding the equipment, the size of the equipment that's going inside the enclosure, and obviously allowing also for the space of any cabling and airflow that are required around those pieces of equipment. We need to understand obviously the IP rating. So this is the rating to do with dust and water protection. Can go from typically 54, 55, 65 up to 66 protection. So 66 would be total protection against dust ingress and protected against strong jets of water with limited ingress of water, which would not affect the equipment. Also, what we need to understand is any EMC requirements. A lot of equipment that goes into outdoor cabinet and indoor cabinet products are EMC compliant themselves. So really it's often just the interconnect of the cabling that needs to be shielded if there is a requirement. But we also do produce some EMC variants of our standard product range as well, should there be a requirement where proprietary equipment does not have any EMC shielding. Climate control, we work with the customer to calculate any thermal cooling or heating requirements, and I'll explain that a little bit in a bit more detail on these slides. So here is the IP chart, and what you can see is this is the area which is the dust protection, and this is the chart which is for the protection against liquids or water, for example. We start off at 1, which is the lowest standard, and then we move right up to IP6, which is total dust type protection. And then again here with the liquid and the cooling, we've got IP1, which is basically protection against vertical falling drops of water and limited ingress permitted, which can't affect the equipment, right up to IP8, which is protected against long periods of immersion under pressure. So when we're looking at thermal management, what we typically need to do is look at the types of heat load, the particular application, will have applied. So that's really the critical first step when we're choosing the cooling system, and you know, and coming out with the right calculation for the goal we're trying to achieve. So the heat load refers to really to the amount of energy that needs to be removed from the space, the chamber, the equipment chamber, and also then the achieved desired temperature that we need to operate that equipment at. And really, there are three levels of heat load that we consider when we're calculating the heat load, and those are the external heat load, the solar load, the heat from the sun, and then the internal heat load. Um, and these types of heat load are important, obviously, to look at really when we're considering the thermal solution, the cooling solution or heating solution that's required. So looking at the external heat load, this can be a solar heat gain. So this is defined really as an increase in temperature of a space or an object as a result of solar radiation, heat from the sun. So anytime really an enclosure will be subject to direct sunlight or solar loading, it needs to be factored into that actual cooling calculation is obviously that heat from the sun. We all know what it's like when we're in a car during summer with the air conditioning off inside the car, how much heat is produced really from the sun, reflecting, radiating into the vehicle. The same happens with an enclosure. The colour of an enclosure is important because that will have a direct impact on the amount of heat that's been generated via the solar heat gain. Obviously, darker colours absorb more sunlight, so there's more heat going to be produced within the cabinet compared to lighter colours which reflect the heat from the sun. So choosing a light colour for an outdoor cabinet is advantageous because it will help reduce the amount of heat load, and we do take that into the calculation, the colour of your enclosure. And obviously the darker the enclosure will really negate really the thoughts around any particular sun shield that may be required, or also when we're looking at the colour we also look at whether it's in shade, because the sun, if it's not directly on it, could be in shade, or there's going to be a reduction in solar heat gain. Heat load, the next source of heat gain is going to be really internal heat load. This is the heat that it's produced by the equipment that's been installed. Obviously, any power to equipment is going to turn into a heat load of some kind, and what we need to do is understand what that heat load is. If you don't have that information from your equipment supplier, what we'll look at is the amount of power that piece of equipment will utilize, and we'll turn a percentage of that power into heat. Obviously, all equipment has an efficiency rating, and the efficiency will allow us to work out obviously the heat load of that equipment. This is referred to really as the core load or the internal heat load from the equipment. And almost all equipment will generate some sort of heat, whether it's a small or a large piece of equipment. And also it will obviously have some impact on the thermal management and what's required, how much cooling is required, etc. So typical examples of heat loads which might be installed into your cabinet may be a UPS, a transformer, PLC equipment, network video recorders, digital video recorders, any communications equipment, power supplies, servers, routers and switches, etc. As I said, all of these units will produce some kind of heat, even fiber optic switching equipment. So what we look at, as I mentioned, are all of the different types of heat load, the external heat load, the solar heat gain, and the internal heat load from equipment being installed. And the results will often provide us with information as to whether it's cooling via a fan using an ambient air temperature. And this is if the customer can operate at an IP54, IP55 rating using a filter media to bring in that ambient air. And really we use fans where the delta T, this is the difference between the internal operating temperature and the ambient external temperature, is above 7 degrees. So if we can, for example, if the external ambient temperature is 30 degrees and we can operate the equipment inside at 37 degrees, then we know we can use active fan forced air cooling. Other options are things like heat exchangers if we need to increase the IP rating, or we need lower delta T figures of within 5 and 7 degrees. Air conditioners are useful if the delta T is below or much lower than the 5 degrees for ambient air cooling. So for example, if the equipment needs to operate at 30 degrees and the ambient temperature is going to be 30 degrees, we'd need an air conditioning unit, because we would not be able to use that ambient 30 degrees to cool that equipment. That equipment's going to produce heat, as I mentioned, internal heat load, so it needs to be cooled in some way, and we would need to use an air conditioning unit in that instance. Other options, if we want higher IP ratings, are Peltier devices, thermoelectric cooling devices, which are pretty inefficient but obviously provide that higher IP rating. So if we look at some of the products that Canon Technologies provide, you can see here we have the Abacus Pro Box. In the first column, it's a single wall, so it's a single skin cabinet which can either be floor or wall mounted. Has an IP rating of IP55 as a passive, non-vented enclosure. It's a low price point, has a low cooling capacity, so we'd use forced air cooling, for example, using fans, and really it's for low sensitive equipment that's been installed, so equipment which is hardened and can withstand harsher temperatures or higher temperature ranges. It's a lower security level than there would be in our other outdoor cabinet range, but often it's mounted high up on the side of a building, etc., so it doesn't need that higher security rating. The next product range is the CType product, which is again a single wall product, which is normally floor, can be wall mounted, which gives that obviously that higher security level, and as typically is an IP55 ceiling, so it's obviously IP55 is dust protected with limited ingress, which wouldn't affect the equipment, and protected against jets of water with limited ingress, obviously, which wouldn't affect the equipment. We can provide ambient cooling, so natural convection free air cooling if it's electrical equipment or very low power equipment which can operate at higher temperatures, for example 70 degrees, or we can install things like forced air active fans or heat exchanger, air conditioning use, Peltier devices, etc. And as I said, we calculate what would be required by yourselves should you have a requirement. Price point is really low to medium sort of price point range. Is a low to medium cooling range of product. As I mentioned, Peltier devices can be used, but because they tend to be a smaller type enclosure, equipment in there doesn't tend to operate extreme temperatures as would in our extreme product range, which I'll cover. SType range, this is a double walled, which has got an outer skin and then an inner insulated and an inner skin. Provides a high degree of protection of equipment which is sensitive to rapid changes in temperature, but also gives a high degree of protection with humidity, so helps maintain temperatures which fall below the dew point, so that condensation and water droplets aren't formed inside the cabinet. Typically it's an IP55 cabinet. We tend to cool either using forced air cooling, heat exchangers, air conditioning, or Peltier devices. And then the next highest range product is what we call extreme. This is used in projects for defense or communication applications where it's in areas, regions like the Middle East or Africa, etc., where you've got much higher temperatures. What we have is a triple layered construction, and basically an outer solar shield. So the outer solar shield protects further the amount of heat that's generated or pushed into the cabinet because of solar heat gain. The triple layer cooling also provides an outer layer which allows air to move around the inner chamber, which is double insulated. We can provide up to an IP65 ceiling, and we use, as I've mentioned before, all of the different cooling mediums from ambient fans, forced air cooling, right through to Peltier devices. So you can see there, really Canon covers the whole range, really, from the low right up to the high end outdoor cabinet protection. So looking at the CType cabinet just as a base product, you can see here this is CType, was typically called a catwalk for cable television applications originally. We've developed it further for rural broadband and business broadband applications, as well as CIS and CIS applications for rail market. As I mentioned, it's used primarily where it's got a lower to medium sort of thermal heat load. Single skin construction equipment is a little bit more rugged to the environment it's been installed in, and we can install forced air cooling fan units which can fit into the roof here, which can be monitored and can either run at a set temperature, set speed, or can speed or slow down depending on the temperature within the enclosure. We often also install things like the consumer unit, which is then connected to the mains power by the civil or the electrical integrator. The SType, or was called Streetwise, was primarily developed for, again, the cable television for active equipment market, but also has been actively used in the mobile phone communications market, the cell phone market, and we further developed it in the transportation market for CIS and CIS applications. As I mentioned, it's a double skin cabinet. You can see here a single skin, a single width cabinet, as well as a double width cabinet with two 19-inch bays, and again you can see some electrical configuration here. Moving on to extreme, again, this, as mentioned, this is for applications with high external heat loads, Middle East, Africa, for example, etc. And you can see this this triple construction where you can see this additional panels on the outside which help reduce the solar heat gain. These have got air conditioning units on these particular product, but we do have active forced air cooling devices as well. So we also have developed a product called Canon Guard. This allows you to monitor remotely via Ethernet connection really what's going on within inside the cabinet. You can monitor temperature, humidity, for example. You can have smoke detection alarms in there. You can have detection to see if a door has been opened on the cabinet. You can have additional things like a CCTV camera installed into the cabinet, which then will obviously provide a feed if somebody does open the cabinet to break in. We can have fire suppression systems installed into the cabinet, all those type of things. And what this system will do is via Ethernet provide an SMP alarm trap, which can then go to a BMS or a DCM system to allow the customer to monitor what's going on at different remote sites. It also allows you to find remotely anything that might be going on. You can have a look at what's going on with fans or ACU equipment, and what you can do is you can actually look to see if any of that equipment, if it's running actively, you can see fan speeds and if any of the faults are on any of those pieces of thermal device. As I mentioned, a lot of our products we've done independent testing. These are examples of IP65 testing on our SType product and Extreme product, and also EMC certification we've done as well for specific projects. Now we're looking at some of the examples of projects that we put together for particular market areas. This is a 5G testbed project, was developed and was based around the CType product. This is an SType product which had heat exchangers installed to the front doors, and it was for the GSM. Our project for the rail market, and this received obviously PADS approval. Like many of our products for the transportation market, we have PADS approval from Network Rail. Here is an example where we've increased the width of an SType design, so we can have a 3-bay, you could have a 4-bay, a multiple bay system. different depths, different heights, etc. And also, but you can see is at the base of the cabinet here, you can see a battery drawer here, which is drawn out on slides and allows you to get access to the batteries during services or test. Again, based around the SType cabinet, we've got an IP65 which uses a Peltier device which sits in the roof of the cabinet area. Here we have an inner chamber which is the IP65 ceiling. This provides a high degree of thermal management and a high degree of IP protection, and was for a project for Crossrail. Again, these are IP55 forced air cooling applications. One is for transportation network rail project, CIS, and the other one is for rural broadband application. One of the things obviously that we achieved and we were happy to achieve was to be chosen by a particular customer to provide the outdoor cabinets for the security surveillance systems which were outside the Olympic Park back in 2012. These were active calling devices. And again, another network rail application. This particular product was developed so it could actually be assembled on site as well, because in some of the locations they were unable to maneuver the product into site because they were in underground ground tunnels or areas where it was difficult to get access to. So they had to be delivered in piece parts, and then our team of engineers assembled them on site. And this is a multi-bay broadband application, and actually shows an example where the roof is lifted so you can get access to the forced air cooling for maintenance and repair purposes, etc. Some additional products here you can see here that Canon manufacture based around outdoor cabinet applications is a retrofit shelter. These were developed specifically for mobile communications, where they've installed third-party outdoor cabinets which don't have a high degree of security, and in specific areas vandalism was a major problem, and Canon developed this retrofitable shelter which actually is craned in position from above the cabinet. It provides still all the necessary cooling to the outdoor cabinet that's housed inside the shelter, but it provides a higher degree of security protection. Other examples are what we call a retro shelter. This is a larger outdoor shelter which could house standard indoor 19-inch racks. You can walk inside these units, and they would include all the thermal management to maintain an operating temperature for the equipment being installed. And again, another network rail project for FTN, which was to house active communications equipment. This is based really around the signalling standard cabinet that the LOC cabinet, which Canon also provide, and we actually developed this based on the LOC standard, but introduced forced air cooling because it was active equipment that was going inside of the cabinet. Well, thank you for your time viewing this